Hello, today I'm going to talk about analyzing quantitative data. First, descriptive statistics. Descriptive statistics can help to provide a simple summary or overview of the data, thus allowing researchers to gain a better overall understanding of the dataset. Because raw data are not in and of themselves revealing, they must be organized and described in order to be informative. Three types of descriptive statistics. 1. Measures of frequency. 2. Measures of central tendency. 3. Measures of variability or dispersion. Measures of frequency. Measures of frequency are used to indicate how often a particular behavior or phenomena occurs. For example, how often learners make errors in forming the past tense. We can use tables, histograms, bar graphs to represent frequencies. Measures of central tendency. Researchers often use one or more measures of central tendency to provide precise quantitative information about the typical behavior of learners with respect to a particular phenomenon. In measures of central tendency, mode, median, and mean are very important. Mode. The easiest measure of central tendency to identify is the mode. The mode is the most frequent score obtained by a particular group of learners. The mode does not always give an accurate picture of the typical behavior of the group. Median. The median is the score at the center of the distribution. That is, the score that splits the group in half. Mean. The most important and significant common measure of central tendency is the mean, or the arithmetic average. Since the mean is the basis for many advanced measures, it is commonly reported. It is a sum of all scores divided by number of observations. Descriptive statistics, as I said, provides simple summary or overview of the data. Types of descriptive statistics, we say measures of frequency, measures of central tendency, measures of variability or dispersion. Measures of frequency, as I mentioned, measures the frequencies are used to indicate how often a particular behavior or phenomena occurs. Measures of central tendency to provide precise quantitative information about the typical behavior of learners with respect of a particular phenomenon, mode, median, and mean. Measures of dispersion. If we only report the mean, we will not be able to show that groups have a fairly different dispersion of the scores. One group's scores are all close to the mean, the other group's scores are widely dispersed. For this purpose, we can use standard deviation. Now, standard deviation, we say that the ST is a number that shows how scores are spread around the mean. The smaller the standard deviation, the better the mean captures the behavior of the sample. Normal distribution. A normal distribution, also known as bell curve, describes the clustering of scores or behaviors. In a normal distribution, the number scores cluster around the midpoint. Standard scores. As raw scores are not in and of themselves revealing, we use standard scores. Two common standard score types are T-scores and Z-scores. Now, Z-scores. Z-scores are standard deviation to reflect the distance of a score from a mean. For example, if a score is one standard deviation above the mean, it has Z-score plus 1. If it is one ST below the mean, it has Z-score minus 1. And now T-score. A second common standard score is T-score. In essence, it's a converted Z-score. Z-scores are often used and expressed in negative terms or in fractions. For certain manipulations of scores, we don't use negative scores. Then we use T-scores. Probability. The purpose of conducting statistical tests is to provide information about the likelihood of an event occurring by chance. The probability p-value is designed to provide confidence in the claims that are being made about the analysis of the data. P-value in applied linguistics is 0.05. Now, alpha level. Commonly accepted level for significance in second language and foreign language is, as I said, 0.05, means 5%. This is also known as alpha level. Alpha levels should be established by the researchers. Now, inferential statistics. The goal of some types of research is to go beyond uncovering information about how a particular group of students learn a language. Rather, the goal is to generalize beyond the results. In other words, such researchers want to make inferences from the particular sample to the population at large. Inferential statistics can allow researchers to generalize findings to other similar language learners, that is, to make inferences. Prerequisites for inferential statistics: standard error of mean, standard error of differences between sample means, degree of freedom, which we show it with df, means number of scores that are not fixed. Critical value. This is the value that we can use as a confidence measure to determine whether our hypothesis can be supported. Parametric and non-parametric statistics, very important. Two broad categories of inferential statistics are parametric and non-parametric tests. They deal with the parameters of a population from which researchers have drawn samples. With parametric statistics, they are sets of assumptions that must be met before the test can be appropriately used. One of the assumptions is that the data are normally distributed. The assumptions underlying non-parametric tests are minimal. Non-parametric tests are generally used with frequency data or when the assumptions for parametric tests are not met. Parametric tests have more power. Parametric statistics, as I said, now types of them are t-tests, to distinguish differences between two groups. We use t-tests to determine if the means of two groups are different from one another. Then analysis of variance, ANOVA, for comparison between more than two groups. We use ANOVA. ANOVA results provide an F value. Two-way ANOVA. For more independent variables, two independent variables, we will use two-way ANOVA. We will have a main effect and interaction effect here. ANCOVA. There might be pre-existing differences among groups. The pre-existing differences must be controlled and the post-method tests need to be adjusted. Here we use ANCOVA. Then when there are differences between groups, pre-existing differences, we use ANCOVA. And MANOVA. In MANOVA we have more than one dependent variable. In order to use MANOVA, there has to be justifications for believing that the dependent variables are related to one another. Non-parametric tests, common ones is chi-square and also Wilson rank sums and Friedman. Power analysis. Power analysis is associated with inferential statistics. We want to know how many participants are appropriate for a particular study. Then we use power analysis. And effective size. An effective size is a measure that gives an indication of the strength of one's findings. It is not dependent on sample size and therefore can allow comparisons, meta-analysis across a range of different studies with different sample size. Thank you.